All right, we're back. Our third presenter today is Koki Sugimoto. He is from the Kansai University in Osaka, Japan. Koki, thank you for being with us today. I know it's late in the evening in Japan, so we appreciate your efforts to be here. So Koki has degrees from Kansai University, and he's currently in the graduate program there in science and engineering. And he is a doctoral student. He's studying changes in lipid metabolism through the lipid intake, and they've successfully prepared scallop oil from internal organs of scallops. One of my favorite foods. And the title of the talk today is Effects of Dietary Phospholipids Prepared from the Japanese Giant Scallop on Cholesterol Metabolism in C57 mice. So, Koki, take it away.
Thank you, Mr. Chairperson, for introducing me. Hello, everyone. My name is Koki Sugimoto from Japan. I'm pleased to the opportunity to tell you about some of our recent work on effects of dietary phospholipids prepared from the Japanese giant scallop on cholesterol metabolism in C57 black 6G mice. The current time in Japan is 3 o'clock a.m. This is the time when I normally be sleeping, but I'll do my best to win the hour. First, I explain about the scallop internal organs. In Japan, the quantities of 450,000 tons per year of scallop are landed, but 40,000 tons per year of scallop internal organs other than adductor muscle are discharged. The internal organs contain N3 polyunsaturated fatty acids and phospholipids, but they also contain toxic substances, so it couldn't be used effectively. We have successfully prepared scallop oil called as SCO, containing low toxic substances from the internal organ of scallop. SCO has high EPA and phospholipids. Therefore, we aim to produce SCO as a health food material that can be a source of N3 puffer. Our previous studies have confirmed to be non-toxic of SCO. In addition, we have demonstrated dietary SCO decreases the serum and liver cholesterol contents in mice, and this effect couldn't be found in other N3 puffer containing oils, such as menhaden oil and krill oil. In the present study, we investigated what are bioactive substances in SCO that lower serum and liver cholesterol content using mice. At first, we have separated the phospholipid of SCO called as SCOPL. As you can see this table, 4 oils were used for animal tests. Soy TG is soybean oil, soy PL is soybean lecithin, SCOTG is almost the same fatty acid composition as SCOPL, and SCOPL is SCO's phospholipid fraction. 5-week-old male C57 black 6J mice were fed high-fat and cholesterol diet. Experimental diet contains 3% soy TG, soy PL, SCOTG, and SCOPL. After 4 weeks, mice were sacrificed, and we analyzed serum and liver cholesterol contents, fecal lipids, liver and ileum messenger RNA expression levels, and liver CYP7A1 protein expression level. Next, I explain the result. Dietary SCOPL diet significantly lowers the serum and liver cholesterol content compared with soy TG diet. Since this effect was not observed in the SCOTG group, the serum and liver cholesterol content lowering effect of SCO intake is considered to be the effect of the phospholipid fraction. It was partly mediated by 2 points. One is the enhancement of the liver CYP7A1 expression level. CYP7A1 is the rate-limiting enzyme in the classical bile acid biosynthesis pathway. The other is enhancement of fecal neutral sterol excretion. Soy PL had no effect of increasing liver CYP7A1 expression level. Therefore, we focused on the increasing CYP7A1 expression level, which is characteristic of SCOPL group, and investigate the mechanism of increased liver CYP7A1 expression level. Next, I will now explain the summarize of results. This slide shows the mechanism of the enhancement of liver CYP7A1 expression level in the SCOPL group. First, the results show increased expression of CYP2C70, which is involved in uricolic acid synthesis in the liver, and increased beta uricolic acid content. Second, taurine conjugated beta uricolic acid is secreted from the liver into bile and absorbed to the ileum. Beta uricolic acid is antagonist of Fxr and then reduces Fgf15 expression level. Fgf15 is known to regulate CYP7A1 expression level. Fgf15 is transported to the liver and suppresses the CYP7A1 expression level. As you can see in this slide, SCOPL is thought to increase liver CYP7A1 expression levels through this mechanism. These results show that SCOPL lowered cholesterol content through an increase in CYP7A1 expression level, which was not seen in fish oil or soybean lecithin. Therefore, SCOPL can be a health-promoting component with cholesterol content lowering effect. Thank you for your attention.
Thanks, Koki. Great presentation. Enjoyed it very much. Very interesting, the effects of different phospholipids and fatty acids on cholesterol metabolism. So we're going to open up questions now to the judges, and we'll go from there.
I might start off this time. 3 o'clock in the morning. It's 6 o'clock in the morning here in New Zealand. So I know how you feel, Koki. It's very early. I just want to ask a couple of questions. The amount of polar lipid in the scallop, what sort of percentage polar lipid compared to triglycerides are there in your scallop oil?
Thank you for your question. About 20% of SCO is phospholipid.
Yep. And you did your studies with your comparison to soybean oil. Would you think that a fish oil might be a nice comparison? In fact, that they have a similar long chain omega-3 fatty acid profile where soybean hasn't, and that might elucidate the differences between the fatty acid profile or the delivery platform, whether in the lipid class?
You can mean phospholipid class.
Or just like the triglyceride form of just a fish oil, compare the scallop versus a fish oil to see whether the fatty acid profile or if it's something uniquely in scallop oil that is actually having a benefit.
Sorry, I didn't fully catch your question. Could you speak a little slower?
Yep, no problem. Have you considered comparing your scallop oil against a fish oil rather than a soybean oil?
Sorry, what? Fatty acid composition, fish oil compared scallop oil?
No, in your in vitro rat or mouse model, have you considered looking at a fish oil, like a different control rather than a soybean?
Okay. SCO have high N3 polyunsaturated fatty acids, for example, EPA and DHA. But soybean lecithin have no N3 puffer. Fish oil have N3 puffer, but fish oil have no phospholipid. So SCO characteristic have SCO have characteristic have N3 puffer and phospholipid.
Okay. Yep. Thank you.
Sorry, thank you.
Thank you very much for your presentation. I would like to understand, in case you would like really to give, you know, this component to human being, how would you tackle this? Would you separate and purify these phospholipids, or are you planning to give this liquid, this extraction directly to human beings? So which format actually?
Sorry, one more please.
So in other words, if you wanted to implement your solution, how would you do? What is next step? What is the next step for your research? What are you going to planning to do next afterwards in your laboratory?
My future research?
Yeah.
Yes. I want to find bioactive substances in SCOPL in future research. SCO's phospholipid fraction is component of about 10% ceramide amino acid phosphate. It is a characteristic swing lipid with a carbon phospholipid carbon phosphorus bond. I think this is a bioactive substance with this effect. So I evaluate the effect of ceramide amino acid phosphate on cholesterol metabolism in the future research.
Okay, thank you very much.
Thank you.
Any questions, Dr. Zetti?
I just wanted to follow up kind of with Fabiola's question. How would this be applied to human models? The research that you've done in mice, but how would you apply it to a human model?
It has been reported N3 puffer is used for human. So SCO is also SCO is effective for human too.
Okay. Okay. Thank you.
Thank you.
Well, thank you, Koki. Appreciate your presentation. Very well done. And look forward to hearing more about scallop oil in the future.